Okay. Hello, guys. I hope you hear me well. I'm sorry, my voice is a little bit because of the party last night, so I'll try to do my best to give this talk. So today, yes, we are going to talk about the Google Play billing. So as usual, a slide about me. So I'm a senior penetration tester at RandResec. It's an offensive security company based in Paris. I have a lot of experience in penetration testing in different areas, such as Windows, Linux web application, Wi-Fi, and of course Android. I'm also a member of the Checkmarks application security research team. I don't know if you know this team, but one of the famous things this team performed is about a research regarding Tinder, the Tinder application. So yes, if you want to dig more, you can look at the blog. I am also a core security researcher at Cobalt, and I like playing CTF. But for Hack in Paris, I didn't get time to play a lot. So let's start. I'm going to present you briefly what is a Google Play billing, present also some known vulnerabilities about this API, show you how I exploited these issues on several applications, and also some results about my research. Maybe before to start, how many people are using an Android device? Okay, so many people. And how many people are already performed in-app payment using their device? Okay. I guess mostly for games? No? Yes, no? No? Okay. So let's have a look at the Google Play billing. So if you look at the Android documentation, the Google Play billing is a service that lets you sell digital content on Android. So yes, it's a good framework for developers because you can use it for in-app purchases, but also for subscriptions. So for instance, to magazines or to have some premium features if you want to remove advertisement on your Android application, or more specifically in Android games, to have some extra content. For instance, okay, Fortnite, it's not a good example because they are not using the Google Play Store to publish their application, but you get the idea. If you want to buy some stuff on Fortnite, if Epic Games wanted, they can use Google Play billing API. Another advantage is that the payment is completely handled by Google. So for developers, it means they don't have to handle with credit cards, track the transactions, and so it's easy for her to implement this API. You just need to define the products on the Google Play console. So you say, okay, on this application, I'm going to sell this kind of product or this kind of subscription, the price for each product, of course, and that's all. And the only requirement on the user, you need to have Google Play installed on your device, which is normally the case if you are not if you have not rooted your device. So yes, if you look at this schema, just to have more an understanding. So in orange here, you have your application. You just need to embed the Google Play billing library in your application. And then you have two important components. As we said before, the Google Play app, which with the application, your application is going to talk about and the Google Play backend. So in fact, when you start the process of in-app payment, your application is going to send a message to the Google Play app saying, okay, this user wants to buy this specific product. And then the Google Play app is going to send requests to the backend for validating, for handling the process payment. So yes, the backend is not used only for that, but also to retrieve the product list that your app is selling, and also for tracking the transaction. For instance, you can imagine you are buying a magazine. If you already buy it, you can retrieve it without buying it again. And then optionally, the developer's app can have a server to perform the payment validation or to deliver the product. If it's not, if you need to deliver the product with a third party. So, just to, if you never use it, it is something like that. So on this example is a trivial drive application provided by Google on the documentation. So if you click buy here, for instance, in fact, you have kind of a pop-up saying, okay, do you want to buy this product? The price is this, and you just need to click buy, and then the payment method is asked. So if you pay by credit card or voucher code or something else. So in fact, this pop-up is already the Google Play app. In fact, when you see this pop-up, you are kind of not anymore on your Android application. And so if the payment goes well and is successful, then you go back to your application, and then your application need to handle this successful payment to deliver the product. So let's have a look deeper on what Google is giving to the application. In fact, it's just a JSON object containing several values, but the most interesting one is the purchase state, which indicates if the payment was successful or not. So you have only two possible values, 0 for purchase or 1 if the user cancels the payment. A purchase token, it's just a token used to identify the transaction for the tracking, and a signature. In fact, this string represents the signature of all the JSON objects returned by Google. So for sure, the idea is for the developer to ensure that the signature returned by Google Play backend is a good one. So yes, to do that, you need just to generate an RSA key pair for each application you are going to use Google Play billing. And yes, the private key is used to perform the signature. So if you look at the code of the Trivial Drive v2, which is again the sample application provided by Google, you can see how the verification is performed. So yes, it's wait. So you have a verify purchase function, and yes, you have some verification to see if the signature is empty, and with the public key, the signature is verified. If it went well, it returns true, and normally the application delivers the product. So if you look at the comment of this class, you see in small that there is a comment saying for a secure implementation, all of this code should be implemented on a server that communicates with the application on the device. So in fact, we are looking at the example provided by Google, but they say be careful. Normally, you shouldn't do that if you want a secure implementation. So it's a little bit strange. If you look deeper on the Google documentation, they tell you, yes, in fact, we recommend to validate the purchase on a server controlled by the developer. However, if you can't, you can still perform a less secure validation within your app. It's allowed with the design provided by Google. But they warn you on the warning, this form of verification isn't truly secure because it requires to bundle purchase verification logic within your app. So it means if someone reverse engineer your application, you're screwed. So let's have a look at some known vulnerabilities already found on this API. In fact, in 2013, Dominic Schurman found already 2 vulnerabilities on this API. So he disclosed the bug to Google. It was on the Hall of the Fame at this time. Yes, at this time, bug bounty it was not very popular, so he didn't get any money for that. But he developed a proof of concept called the billing hack to perform to exploit the vulnerabilities found. So let's have a look at the first one. So in fact, as I said before, to start a payment, you need to send a message, which is in the Android world means an intent, to the Google Play app to initiate the process payment. In fact, at this time, he found that if a malicious application defined in this Android manifest a specific filter for the message sent by the application with a high priority, so it means you are telling the system, okay, if you send this kind of message, I want to be the first in priority to receive it and to manage it. So in fact, it means you can impersonate the Google Play app. So that was the first vulnerability found. Then, when you look at the signature verification method given by Google, he found that, in fact, if you return an empty signature, you can see on this code, in fact, the function always returns true. Because the first test is, if not empty, make the verification. In the other case, if the signature is empty, no verification is made, and by default, the function returns true. So to sum up, you can just create a malicious app at this time and set an intent filter with a high priority to impersonate the Google Play app, return an empty signature, and that's all. You can bypass the payment. So of course, Google modified this. For the first one, it's simple. They say, okay, for now, for the intent, you need to specify specifically that we need to use, you need to send, this message to the Google Play app. So on the Android world, the package name of the Google Play app is com.android.vending. So now each Android application wanting to perform in-app payments need to implement this specific line. You can see service intent.set package and specify com.android.vending. Okay. So that's for the first one. Okay, so now we are sending the message directly to Google Play application. And for the second issue, it's easy. They just modify the verify purchase method, and by default, it's returning false, whatever, even if the signature is empty. So that's cool. So now the question is, can we remove a client-side issue using a client-side fix? Spoiler alert, no. In fact, you can still bypass the payment even with those fixes, because if your Android application is still performing local validation for the payment, you can still modify the application to set the package to an application you control, and modify the verify purchase method to always return true if you want. So in fact, the main problem, the first point is simple to automate and to do. It's just the second one. You just need to find the logic for the verification process, and just to modify this logic. So hacking steps, if you want to do that, it's pretty simple. Use the billing hack provided by Dominic. The proof of concept is still available on GitHub. You have it on my slides on the reference at the end. You decompile the application, for instance, with APK tool. You modify the bytecode to replace the package with a billing hack application. You modify the signature validation to return always true, recompile the application, install it new in your device, and that's it. So now let's have a look at some vulnerable application. For the first one, I tried on Doodle Jump. In 2015, it was one of the famous games on the Android platform. If you don't know this game, you just have to jump the higher possible to win the game. So in this game, you can buy kind of costumes But to buy costumes, in fact, you need candies. So the only item you can buy is candies. If you look at the code of the Google of the Doodle Jump, sorry, application, in fact, it's like it's a copy paste from the Android documentation. So they said well, they set it well, saying the set package to the Google Play app. So now it's mandatory, so they can do another way. So on the bytecode, it's easy to replace just a string com.android.vending by org.billing-hack. Okay, so no problem for that. And if you look at the Java code, yes, the verify purchase is here. So the verification is performed locally, so no issue. On the bytecode, you just modify the v0 register here to be set to 1, which means true on bytecode world. So doing that, you just have to recompile the application and to use it and to profit. Just a quick demo to show you I'm not cheating. In fact, yes, in some stuff I'm cheating, but not for the demo. Okay, so you see I'm going to launch Doodle Jump. So sorry, it's in French, but I'm going to make the translation. So if you look here, you have the magasin, which is a shop in English. Okay, and so you can select a character. So the first ones are free, but for instance, this one, you need to have 1,000 candies to play with it. And you can see I have 0 candies at the moment. Okay, so let's select one. I'm going to choose the pumpkin one because I like it. Okay, so you don't see it, but I'm going to click on buy. And so now it's telling me, hey, you need more candy. Of course, I have 0 candies. So I have 3 options. I can watch a video to obtain 200 candies, but it's not enough. I can buy 1,000 or 10,000. Okay. So on this example, I'm going to be reasonable. I'm going to click only on 1,000 candies. And you'll see a pop-up, but it will not be the Google Play pop-up, we can say, but the billing hack pop-up telling me if I want to buy this item. So yeah, the pop-up is just for demo purposes. Okay, so you see the pop-up. Do you want to get this item for free? For sure. I'm here for that. And yes, sorry. And so yes, now you can see I have 1,000 candies. So that's cool. I can buy this character. So that's a Doodle Jump application asking for that, if I'm sure I want to play with Pumpkin. And now they are not asking money anymore. I mean, candies in this case. And I can play with it. Okay, so that's it for Doodle Jump. So you can see Doodle Jump is like the 101 in-app payment validation. They are only using the documentation and don't thinking about how to secure the payment process. Let's have a look to another example, Snoopy Pop. So it's a funny game. It's pretty similar to Bubble Witch if you know it. In fact, it's not similar. It's the same, but you are playing with Snoopy. It's the only difference. In this game, you can buy coins and leaves, as you can see on the right. So, on this case, Snoopy Pop, they are using the Unity library. I guess if you play a lot, or not a lot, but if you play video games, you can have heard about this library because it's used for graphics. And in this library, they are offering kind of an interface also for the Google Play billing. If you look at the documentation, they say, okay, we have 2 ways to handle the payment. the validation, sorry, you can do it locally or remotely. Cool. But if you look at the remote validation, you can see, in fact, Unity does not offer support for server-side validation. Too bad. So, in fact, Unity in the last versions are mostly developed in the Mono.NET, and so those DLLs are embedded on the Android application. If you look on the assets directory of the Android application, at some point on the manage subdirectory, you find a lot of DLLs and one interesting called security.dll. And because it's .NET, it's cool because we can decompile it easily without debugging assembly code for hours. And if you look at this DLL, there is a function called validate with the same purpose of the verify purchase method I showed you before, which validates the signature of the purchase. So we can use, for instance, a well-known tool called DNSPy, which is a .NET decompiler. So we can obtain the C# code without any issue. And in red here, you can see that if the signature verification is not good, an exception is thrown called invalid signature exception, and so the payment is not done. Okay, so no problem. With DNSPy, we can decompile, but we can also modify the DLL without any issue. So just remove the lines throwing the exception, recompile the DLL, and embed it in your application, and you can profit. So another demo, just to prove I'm not cheating. So yes, I can show you quickly DNSPy. So here, it's the security DLL open, decompiled. On the Google Play Validator class, we find the validate method here. And here you can see, yes, if flag up, we return an exception. So just select the lines, edit, and normally, if I'm not wrong, yeah, this one, this one, this one. Okay, that's okay. So now we don't have any more the lines throwing an error if the payment is not done. And so after repackaging your application, you have my emulator. I hope you see well. So of course you launch Billing Hack to impersonate the Google Play app running in background. You launch Snoopy Pop. Okay. You already see I have a lot of coins and my lives are full. I don't have connect. Okay. Fail. Okay, demo gods are not with me today. I forgot to set up internet. You need the internet to make payments. Okay. Okay, I'm going to set internet and I'm going back to this demo. Sorry about that. Okay, so the last one is Fruit Ninja, which is a famous game also, more than 100 millions of downloads. And so this one is more, we can say more secure, because they use Java native interface. So if you don't know what is Java native interface, in fact in Android application you can embed native code. It means you can embed in fact shared libraries. Usually those libraries are written in C or C++. And so the idea is from your Java code, you can call methods on this shared library. So those functions are pretty easy to find on the Java code because you just have the definition of the method and the native keyword is used. So it means if you want to see the implementation of this method, you need to reverse engineer the shared library. And in the case of Fruit Ninja, all the sensitive functions for the payment are handled by the shared library. In fact, you can see here the purchase result native in the middle is the one performing the validation of the payment. So I found the shared library. It's pretty easy. You need to be a good reverse engineer. I tried. I failed because it was time consuming, and as I said, I'm not really skilled for reverse engineering. But at some point I say, okay, let's try it and see if it works. And finally, it appears that I don't know what they are doing in the shared library, but the signature validation is poorly made, and so you can also bypass the payment. So normally, if I have internet access, yes, it seems okay. I can show you. So first, with doodle jump. Oh, you're kidding me? Okay. You are lucky you don't have the sound, so don't complain. Oh, my internet connection is not enough. Okay, let's try with Fruit Ninja. Okay. So yes, you can on Fruit Ninja you can buy some golden apples and some stars. And so normally, let's try with golden apples. Just 250. Okay, I don't know why there is a bug with the screen. It comes black, but at the end you can see that it's working. And it is the same. Oh. Okay. It doesn't like it. Okay. Okay. And so it works. Let's try again just to be sure with no pop-up. Ah. Okay. Okay, no, it doesn't want. I don't know why. Okay. Sorry about that. So that's all for the vulnerable application. So let's go to the conclusion. So as I tried to show you, developers use different techniques to protect the Google Play billing payment. So sometimes they try to use obfuscation from what I see on the different Android application I tested. Shared library, you see some shared libraries in .NET and other ones using native code. And sometimes nothing at all, like Doodle Jump, where there is no improvement in security. But yes, unfortunately, if the signature validation is only performed locally inside your application, you have no way to protect the payment. So I tested roughly more than 40 apps. 25 apps were vulnerable. I was able to bypass payments. I can show you all the Android apps I found because some of them didn't respond at all on my solicitation. I find only 5 apps using an external endpoint to perform additional check regarding the payment. All the application I show you, I contacted the editors. I contacted Fruit Ninja, the Snoopy Pop, and also Doodle Jump. Doodle Jump, I never got an answer. Fruit Ninja, they told me, well, yes, we are going to fix it. Still not, but there are some updates, but still not fixing this particular issue. And Snoopy Pop, no answer also at all. If you compare the billing, the Google Play billing library, you can see that Google is the only one providing a design where allowing the local validation. If you look at the Amazon in-app purchase or Samsung, for instance, in-app purchase, you can see on the documentation that the requirement is to use a server to validate the payment and to retrieve the product you are selling. Okay. So I just want to thank Checkmarks for the support on this project. And yes, I think we have plenty of time for questions if you have some. Yeah, in fact, what I found, for instance, there is a newspaper application. In fact, when you made the payment, I was able to bypass it. But at some point, because you need an account to be authenticated, to retrieve the magazines or to obtain the access premium feature, premium access, sorry. At some point, they make the server is making a kind of a request to the Google backend to be sure that you made the payment. So even if you bypass it locally, at some point there is another check to be sure. Okay, you are a premium user. In fact, it doesn't appear you have paid on the Google backend, so we are not going to accept. Wow. Okay. So the technique process you demonstrate with Doodle. So I guess it's Doodle Jump. Is it the same used by apps like Looky Patcher? Yes, in fact, it's the same because Looky Patcher is also based on the work from Dominic Schurman. So, in fact, if you look at the Looky Patcher application, it's based on the same work as Dominic. So, it's based on the billing hack application. So, sort of Looky Patcher is just an improvement of the billing app application. Did any of the application ban you? At the moment, yeah, I didn't get this point of banishment. I mean, I used Through Ninja for several times and I didn't get banished. But I don't think they can banish me because if you are not using, sometimes applications are asking you to use your Google account to save your status. If you don't connect, you can still use the application and make payments. So I don't see any means to banish me on the game.